Welcome back. And on this video, we are going to talk about option pricing. And we're going to use the Black-Scholes model to calculate or estimate the value of an option. So we will start with some piece of information. We have the current price of the stock at $40. Let's say the option expires in 2 months, that the strike price or exercise price is $40. Let's say the risk-free rate is at 9% right now. And let's say the standard deviation is at 30% for this asset that we're evaluating. Now, to use the pricing model from Black-Scholes, we're going to be using these formulas here. So the goal is to get the value of a call option. That is the goal, and this is the formula. Now, before we start entering these values in the formula from here, we do need to find D1 and D2. D1 and D2. So we got to calculate that first using this formula for D1. And once we find that out, we can input that number in there and then do the rest. For D2, we also going to use the value that we get from D1. We will use it there, and then some information that we have over here on the left, and we get D2, and it goes in there. Once we solve that formula, it's going to give us the value of the call option. Then we have this thing called put call parity, which through this formula down here, we can then use the value of the call and some of the information available here to then get the value of the put option. So we can get both values by calculating the call option first, and then using the put call parity to get also the put option value. So the way this table is going to work, instead of us having to do all these formulas in one place, we first are going to break it down. We're going to calculate D1, then we're going to calculate D2, and then we can calculate the ND1 portion in there, and then we'll calculate the ND2 portion. And once we have those values, we can go ahead and put it all together to get the value of the call, and then the value of the put option. So let's start with this piece here. All right. So D1. It says that we need to start with a natural log, ln. In Excel, fortunately, we can say ln to start getting the natural log of that formula. And we're going to go ahead and grab the price. That P is the price. That's we have a P there. We're going to divide it by the exercise price, because we have the X here. That's part of the formula there. All right, now we have to add. We're going to start adding this stuff. So we got the risk-free rate. We're going to add that, but it's also adding within that bracket the variance divided by 2. Now, so what do we have? We have the standard deviation, but we know that the standard deviation can be squared to get the variance. And then that can be divided by 2 as the formula dictates. We are going to close that piece and multiply it by the time. And then we're going to close that entire top portion. So that takes care of our top portion. Now we're going to put a division sign to get this last piece at the bottom. So I'm going to go ahead and also put a parenthesis just for good form. So we need the standard deviation, not the variance. So we can just click on the standard deviation here, not square it. But we do need to multiply it by the square root of the time that is left in the option. So we're going to go here. And then we're going to go ahead and Close that bottom piece out. That is our formula for D1. Okay. Now D2, it's a little simpler. All we're going to do is follow this formula. So all we got to do is, now that we have D1, we can start by getting D1 minus the standard deviation multiplied by the square root of the time to expiration. And that takes care of that piece. So now we have D1 and D2 that we're going to use in here. Now this N is because we need to get the, it represents the normal distribution probability. So we're going to talk about a function in Excel that's going to give us that N. So that N in Excel means normal distribution. Now for the X on the normal distribution, we want to get allow me 1 second. Let me start that one again. Okay, norm distribution. We are working with D1. So we want to let it know that that's our X value. That's the value we're working with. And the rest is just a formality. We're going to say that has a mean of 0, because when you look at the normal distribution and it's standardized, 0 is in the middle as your average. And then standard deviations in increments of 1. You get 1 standard deviation, 2 standard deviations, it's going to be in increments of 1 there. And then it wants to know if it's a cumulative or probability mass function. We are going to be working with the cumulative distribution function. So we want to write the word true there. Once we have that, just hit enter, and that gives us the probability of the D1 value. Now, this piece here is also known as the hedge ratio. We're not going to get into the hedge ratio right now, but it's good for you to know because it's used for other transactions, other strategies. But just so you know that when you calculate this piece, it's also the hedge ratio. Okay, so we're going to do in D2, we're going to follow the same process. We're going to hit the normal distribution function. However, we are now using D2, but the rest is the same. We're going to put a 0, a 1, and we want a cumulative. And that gives you the ND2 portion of the formula. Now we just got to finish the last detail here, which is to bring all the pieces together. So what do we start with? We start with that P for price. Right? We're going to multiply by the ND1, which we already have here, minus the exercise price, which we have here. And that piece is multiplied by the Euler number. So in Excel, we represent that with EXP, that's the function, EXP function, and it wants a number. We're going to work with this number. That's going to be the exponent that belongs to the Euler number. So it's going to be negative risk-free rate. So you want to put the negative there of the risk-free rate. This is the discounting piece of the formula and continuous discounting. So that's why we got to put the negative. Times multiplied by the time left on the option. And then all that together gets multiplied by the ND2 that we calculated as it calls for here. So we're going to put the ND2 there. Then we hit enter, and that is the value of that call option based on this information. So $10. Now we can actually get the value of the put option by following the put call parity formula. So what you do now is we are going to get the value of the call option minus the price plus the strike price, but multiplied by the Euler number. In this case, we're going to use the EXP function. And we're going to follow the same thing. Negative risk-free rate times or multiplied by the time left in the option. And that concludes our part there. And now you have the value of the call option, the value of the put option based on the information given here. Now, here what we did, we broke it down in pieces so you can see, but you can do it all together in one cell. I have that already set up here, so we don't have to go through it all again. Now, it looks a little messier, but the idea is that we used only the values that were given. Now, notice the price is not included there because we're using this stock price here with intent to be able to just have a table that you can just copy and paste or drag the formula all you want. Let me put that in the video there again. That's what it looks like. You can pause the video, want to kind of follow that formula and give it a try. And on the put value, this is what it looks like using the price over here, not over here, because we're going to change the price as we go. The idea is to be able to drag, copy, paste the formula, etc. So as a put value, notice we're getting the, well, $25, we get those values. We'll compare in a second. Now the hedge ratio, this is just the same number we have here, but this was going to look like if you don't do the breakdown steps and you just put it all together in one place. Now this was done with $25. That's why these two numbers are not the same. But let's go ahead, since these are already set up and the proper cells are locked in place. We're going to drag this down. It's going to give us the formulas or the results for all of these. And let me go ahead and format that piece. So notice here on the $40 one, we get the same result, $10, $3.41. And if we were to change to any of these prices here, let's say 25, it will update the formula. And you see then that now matches the same values in the hedge ratio and everything. So here you can just punch in different numbers and update the formula, or you can build a table and then just drag the formula you want to as many values that you want. Notice also that if I can change the time to 3 months, it updates all the values. And if I go ahead and update, let's say it's only 1 month away, it updates all the values. 1 month and $25, it updates all the values. Okay, so that's it for this video. That is how you calculate option pricing and with the Black-Scholes model in Excel.